point. So let's go to the chapter 15 handout. We covered all of this, and we're going to start from here today. And I believe we did these 4 last time, right? Can someone just confirm or deny that for me? Yes? Okay, cool. So chapter 15 kind of is in layers, and it builds on top of each other. So the first layer was what we covered with activators, deactivators, and just this table that we made here of the different kind of reactions. So that's step 1. Step 2 is going to be kind of learning these stuff about Friedel-Crafts and all the different like exceptions and stuff. And then level 3 is going to be multiple substitutions. So today we are going to finish up Friedel-Crafts. I know we started it last week, but it was my mistake. I did that before directing effects. So we're going back to Friedel-Crafts, and we're going to do that now. So Friedel-Crafts have a couple limitations or special things we have to think about. So for alkylation, does anyone know what those limitations are? And then someone said we already did the limitations. I know that we had done it, but I figured we should do it again. Do you guys want to, or do you not really care since we've already done it? Just let me know. People are already answering, so we'll just do it really fast. So, yes, you guys are right. One of them is rearrangements. One of them is polysubstitutions. And the other is that it will not happen with NH2 or a strong deactivator. And I'm just going to copy and paste because I'm lazy. But the acylation is going to be the same. Is going to be the same limitation where it will not happen with NH2 or a strong deactivator, but it will not have rearrangements or polysubstitutions because instead of having an R group, it's an acyl group. So that's pretty much it for limitations. It's not too much. It's just remembering what goes where. But just remember the reason that these 2 things happen is because of the carbocation. Any questions? And I'm still a little bit sick, so please excuse my deadness. Okay, no questions it seems, so let's move on here. So Friedel-Crafts reactions, I believe we already did these 2, so I'm just going to do this one more time to remind you guys. If we make our electrophile, we're going to have this carbocation right here. Is this the most stable possible carbocation? No, we could do a rearrangement and make a more stable one. So what kind of rearrangement can we do? A hydride shift, exactly. So we're going to do the hydride shift, and we move the plus charge here. And so now, when the benzene reacts with that, instead of adding to this position, it will add here. So, I don't know why I did it like that. It will attack right here, and we end up adding a secondary carbon, like so. Any questions about how I did that, or what I did, or why? No? Okay, cool. So, here, they're actually both kind of trick questions. So, why are these 2 trick questions? What do you guys think? One person said it, but I want a couple more people to at least try. Exactly. So someone said there's no reaction. Someone said because of strong deactivator. Someone said because of NH2. So you are all correct. So this group right here is a strong deactivator. And this one is part of the exception, but is it a deactivator? It is an activator. So I'm going to write A for activator. And it's actually the strongest activator. And I don't remember if I mentioned this to you guys, but the reason NH2 doesn't work is because it's such a strong base that will get an acid-base reaction instead of a Friedel-Crafts reaction. So in this case, it will be no reaction because it's such a strong deactivator, it doesn't allow this to be added. And this is no reaction because this is such a strong base that instead of an electrophilic aromatic substitution, we will just get acid-base chemistry. So it'll be no reaction, and again, no reaction. So up here, down here, we're going to go ahead and do some examples. I'll zoom in for each one, and then I'll zoom back out at the end. So in this example, we know that when we make the electrophile, we get this carbocation. Is this the most stable carbocation? No. Cool. Okay, so what can we do to rearrange it? What kind of rearrangement? Cool. Pretty much everyone agreed on methyl shift. So when we do a methyl shift, we're going to move one of these methyls over here. Over here. And now our plus charge moves over here. So it became tertiary. Is there any better rearrangement we can do? Nope, that's as good as it's going to get. So now we really have this reaction. And all we're going to do, doesn't matter which position on the ring we add it to. I'm going to add it here just because that's the one with the most free space. So we are attaching to a tertiary carbon, and then it has one more carbon attached to it. So this would be our final product. Any questions? I'm trying to go a little bit faster. Let me know if it's going too fast or if it's still too slow or whatever it may be. Okay, so this next one is actually a multiple substitution reaction. So first thing we have to do is identify what this group is. Is this an activator or a deactivator? Deactivator, cool. And then you guys can just say A or D because you don't have to write out the whole word. So is this a strong deactivator or a weak deactivator? Strong, cool. So remind me, what is the only thing that will be a weak deactivator? Halogens, exactly. Halogens are the only weak deactivators. Cool. So will this work before we do anything else? No, correct. This reaction will not proceed. Cool, we're done. If it were going to, just for practice, strong deactivators are going to direct where? To what position? O, M, or P? Meta, exactly. So I'm going to draw an arrow to the meta positions, but it's no reaction, so it's not going to happen. Cool. In this next one, we have our carbocation formed right here. Is this the most stable carbocation? And then someone actually said, someone asked a question. Someone asked, how do you know if it would be a multiple substitution if the reaction works? And then someone said, so how do we know that it's no reaction? So I'll go back and answer both of those. So a multiple substitution reaction, all that means is that we already have something on the ring, and we're doing a second or third reaction to add something else onto the ring. So let's say this was any other thing besides Friedel-Crafts. First thing we would do is look at this group, identify it as being a strong deactivator. We also know that it's meta-directing, so I'll also write that down. And so I then am going to draw an arrow to the meta positions just so we can keep track. And so whatever reaction we're doing next, we're going to add that group to the meta position. But in this case, we saw that it's a strong deactivator with a Friedel-Crafts reaction. We know that's not possible because Friedel-Crafts cannot happen with a strong deactivator or NH2. So we know that this has to be no reaction. Please let me know if that was a better explanation. Got it? Okay, cool. So for this next one, someone actually got it before I even said it. So good job if that was you. Yes, we have to do a rearrangement, but we're actually going to go ahead and do a ring expansion. And this is a little bit weird because if we were to do a hydride shift, we get that tertiary, right? But if we do a ring expansion, and for the purposes of showing you guys this for the first time, I'm just going to keep track. I'm going to number my carbons. So I'm essentially going to break this bond and attach carbon 6 to carbon 2. So I'm going to get a 5-membered ring. And let's go ahead and 3, 4, 5, 6, 2, 1. I numbered that in a really weird way. That's just how I keep track. So now I know that my plus charge moved to which carbon? What do you guys think? It was on carbon 2, but now carbon 2 has 4 bonds, so it actually moved, you guys are right, to carbon 3. It doesn't really matter in this case, as long as you know it ended up on one of these sides. I just wanted you guys to have that practice. So it does, in fact, go to carbon 3. And even though this is secondary and this is tertiary, this is your best option because now you have less ring strain. You have a more stable ring. There will be a question, I'm almost positive, that has this here, and you will have to do a ring expansion. So just know, in this case, ring expansion is favorable. And now at this point, our benzene can attack. And remember, you're going to attack plus charge. So we're going to have a line. It's going to attach to our plus sign, or to our cation. And then we know that 1 carbon over, we have a methyl group. Like so. And then there were a couple questions in the chat. Okay, so both people asked pretty much the same question, and it was, can we do a hydride shift now in order to move the plus charge and make it tertiary? So in this class, no, I don't remember in Orgo 1 if you could do multiple rearrangements, but in Orgo 2, we're just going to make one rearrangement, and we're going to choose the one that's the most favorable. And someone asked, when do we know whether it's hydride versus methyl? Great question. And so the rule I'm pretty much going to give you guys is do whichever one makes the most stable carbocation. And so, for example, let's say this one, right? Or actually, let me draw one out. So let's say we have this carbocation, right? You could either do a hydride shift and get the positive here, or you could do a methyl shift, but you just end up with this, right? So yeah, cool, it's secondary, but we have our tertiary option. So this is going to be better. For an example like this one, we couldn't even do a hydride shift because this is tertiary, so we know we have to do a methyl shift. For one like this, we could either do, we can't really do a methyl shift, you would have to do a ring expansion, but we could either do a hydride shift and move it right here, or we could do a methyl shift and do something like this. In that case, this will be more favorable because we want the ring expansion. We want that bigger ring. I don't know if that was helpful, Hannah. I tried to show you kind of examples that would likely show up. Okay, cool. And then someone said, why didn't the positive go on C2? So, great question. If you kind of look at it, we have two hydrogens here, one here, two here, like this, right? So we break this bond, and this carbon is now going to attach here to carbon 2. So once we get here to where we already did the ring expansion, carbon 2 still has a hydrogen, carbon 6 still has 2 hydrogens, and carbon 3 only has 1 hydrogen. So when you look at it, carbon 2 has 4 bonds, carbon 6 has 4 bonds, but carbon 3 is left with only 3 bonds, so it's going to be a plus charge there instead. And then a couple people asked, is ring expansion always favorable? Only in this case, well, not only in this case. If you have a 3 or 4 membered ring, ring expansion is always going to be favorable. 5 membered rings, it depends, but we'll say, sure, do a ring expansion. 6 and above, you don't need to do a ring expansion, because those are already super stable. So ring expansion will be preferred for 3 or 4 membered rings, because those suck. But if I had to take a guess, I would say it's going to be a 4-member ring, because that's the most obvious one that we practice with on the exam. Wink, wink. All right, really, really, really good questions. Any more questions on this before we go on to the next one? Okay, I don't see any yet, so we're going to move on, and then we can always come back to it. So in this case, now we're doing the Friedel-Crafts acylation, and remember, I'm going to stress it a little bit. When we do the acylation, we always get rid of this dude, and the other side stays on. So all we're going to do, draw a benzene ring, and we add a bond to the carbonyl carbon, and the other side will stay exactly the same. So we get this. Same exact thing for this example. People just think it's weird because now it's a benzene ring being added to a benzene ring. Doesn't matter. It's going to be the exact same. So we cut off this guy. We keep our benzene ring. We attach it to the carbonyl. And the other side of the carbonyl stays exactly the same. So you get this guy. Any questions? In my opinion, acylation is super straightforward because all you're doing is cutting and pasting, essentially. Any questions? No? Okay. So this last one is an alkylation again. So we're going to go ahead, cut that off, and we get this carbocation. Is that the most stable carbocation? No. Okay, so what are we going to do? Methyl shift, hydride shift, or the other one. Ring expansion doesn't even make sense, so let's not even pretend it's an option. Okay, so everyone said hydride shift. Exactly. And so when we move it over, we get this. Other than being secondary over primary, what is an added benefit of this carbocation? Exactly, the benzylic position. Cool. It's stabilized by the benzene. It's great. So let's say we had like the same thing. Hold on. I don't know why I erased that. That was stupid on my part, but that's okay. So let's say we had this, right? Same exact thing, except we have an extra carbon. It would still be more beneficial for you to do a hydride shift and move it here, because then it will be on the benzylic position. So it goes from secondary to secondary, but it became benzylic. Make sense why I did that? Anybody lost? I know I kind of brought it up out of nowhere. Okay, cool. And then someone asked a question. I'm just going back and looking for it. So they asked, would we need FeBr3 instead of AlCl3? So no, I'm not exactly even sure why this is, but just know every time we do Friedel Crafts, it's going to be AlCl3. Okay, so let's go ahead and just erase that extra carbon. Sorry, I forgot the word for carbon. So the final product will be our benzene ring. We're going to attach to that secondary position. And so this will be our final product. I rotated this around a little bit just so it would look better. So this methyl right here is the one pointing up, and the benzene ring is just pointing the other direction. So let me go ahead and highlight our final products. And I will give you guys like 30 seconds or so just to look at the page completed. And let me know if you have any questions, comments, or concerns whatsoever. And then I'm going to throw out an idea to you guys in a moment. Okay. Oh, actually, let me send out the attendance sheet because I forgot. And we're going to take a 2-minute, not break, but I want to talk to you guys about something. So while you let this sink in, I want to ask you a question. So since I was absent for one SI session, we did kind of get a little bit behind, and I don't want you guys to feel rushed for the exam. Katrina and I are going to do an exam review next week. We're waiting for confirmation, so I'm not going to give you guys a date and time yet. But there will be a review. In addition to the review, I was thinking either on Wednesday or Friday, I can have an extra hour of SI for you guys. Everyone already? Yes. Okay, so do you guys want, I'll give you 3 options, and then you guys can let me know. So Wednesday, from 12 to 1, when your lecture time would be. Friday, 12 to 1, or Friday from, my SI is from 1 to 2, so from 2 to 3. A, B, and C. So let me know in the chat what you guys think. Someone said say less. That's so funny. Okay, so most people are picking Wednesday, so I'm going to circle that for now. I could do that Wednesday, and then from then we can just kind of see where that goes, how much we get through on Wednesday, and I'm not making any promises, but if you guys still don't feel confident, I might be willing to do Friday as well from 12 to 1. So let's see how Wednesday goes, and then we can decide from there. Sound good? Okay, cool. You're very welcome. I hope that made you guys happy. And then someone said, are these just extra SI sessions? Yeah. So I will send you guys like a confirmation email, and I'll write that down because I will forget. And it's going to be this week. So this week, Wednesday, from 12 to 1, when you guys would normally have lecture. Since you don't have live lecture anyway, Dr. West gave me permission to like hold extra stuff. So the SI session is usually from 11 to 12 on Wednesday. So then I'll just make a second session to be 12 to 1. And then I'll have my tutoring after that, like normal. And then someone said, isn't our exam next week on Friday? Yes, so your exam is either next week, Thursday or Friday, depending on which session you're in. The exam review will be next week. I believe it will be Wednesday. I lied. It will be on Monday next week because you guys have off Wednesday. I don't know what holiday it is. But this week, so November, today is the 2nd, so this would be November 4th, and this would be November 6th. So you guys chose Wednesday, November 4th, between 12 to 1. I'll hold an extra SI session, like during the period when you guys would usually have lecture, just so we can cover a bit more stuff. And then once we do this, we'll see where we are. Ideally, we'll be at least halfway done with chapter 16 by that point. If not, we can also do the same thing on Friday. But no promises about Friday yet. And I will email you guys a confirmation for Wednesday. Okay, any more questions? Are we good? Everyone happy? I wish you could send like a thumbs up in here or like emojis. That would be so useful. But alas. Someone said thumbs up. I love you. Okay, so cool. Well, let's get back to business. So this is the last question. Oh my gosh, someone sent a thumbs up. Wow, I'm jealous. Anyway, sorry, focus. Okay, so back to material for now. So which of the following can undergo Friedel crafts? This is an exam-like question. There will definitely be a question like this on the exam. So when he asks for something like this, you're looking for can undergo. So you're kind of looking to cross out anything that has a strong deactivator or NH2 or anything like that. So what do we think of this one? Activator or deactivator? Strong deactivator, exactly, so that one will not work. What about this? Yep, not going to work because, again, it's a strong deactivator. What about this one? No, again, strong deactivator. Yuck. Okay, what about this group? Okay, so I'm kind of getting two answers here, so let's really quick. This is what is attached, remember? This is just kind of like whatever's on it. So is this going to be an activator or a deactivator? Exactly, it's going to be an activator actually because it has these lone pairs. So an activator, as long as it's not NH2, will work. Okay, so what about CN? What do we think of that? Nope, not gonna work. Strong deactivator, exactly. Alrighty, and what about bromine? What do we think about that? It is a deactivator, yes, but it's a weak deactivator. It's a halogen. So yes, it actually will work. Because weak deactivators do work, only strong deactivators will not work. So you won't have any like multiple of the following are correct, like A and F or whatever. But just for practice, these two were in fact correct. And someone asked, this is weak directing, and yes, it is ortho para. This is a weak deactivator, and it's ortho para directing. I said that kind of weird. So just to reiterate, in this one, both D and F would work for Friedel-Crafts. The rest of them would not because they're all strong deactivators. Any questions? No? Okay. So let's go on. We already did this stuff. So we're going to move on over here. And we're going to go ahead and practice some more multiple substitutions. So we already did these ones. And just to review, all we had to do is look at the substituent that's already on the ring, and you guys tell me, is it activator, weak deactivator, or strong deactivator? Strong deactivator. Cool. So where does it direct? Meta. Sweet. Okay, so I'm going to highlight those are the meta positions. And when SO3 is our reagent, what group are we adding? SO3H, exactly. So SO3H will be added to our ring. So now it does matter where we add the group, and we're going to add it meta. Remember, there's technically two products. I could run it on the other side as well, but they're exactly the same, so we're not going to do that. And someone said they thought it would be no reaction. So remember, no reaction would only be in the case of Friedel-Crafts. So that's where it gets kind of tricky. Strong deactivators will react with everything besides Friedel-Crafts. So since this is a sulfonation, technically it would go through. In reality, though, like, we know that deactivators obviously deactivate the ring, so it makes the reaction a lot harder to happen. So in reality, like in chemistry, sometimes it wouldn't happen, but for the purposes of this class, strong deactivators would only be no reaction in the case of Friedel-Crafts. And the same is true for NH2. So NH2 would only be no reaction in the case of Friedel-Crafts. For the purposes of this class. You're welcome. Okay. So now that we've done that one, we're going to go one step up, and we're going to do two things already on the ring, and we're going to substitute one more. So this is where it gets a teeny tiny bit more difficult, because now we have two things on the ring. So I'm just going to do like one example to show you guys, and then we'll continue on Wednesday, because I don't want to overwhelm you guys. So when we have multiple things on the ring, we go ahead and identify both of them. So CN is what? Activator, weak deactivator, strong deactivator. Strong deactivator, exactly. And so it directs where? Meta. Perfect. And what about this tertiary nitrogen? Strong deactivator, weak deactivator, or an activator? What do you think? Strong deactivator, perfect. And so, where do we think it directs? Meta, fantastic. Okay, so I made an oopsie. I was supposed to do them in 2 different colors, so don't mind me. All right. So meta compared to this group would be this position right here and this position, but it's already taken, so we don't write anything. Meta for this would be this position and this one, but it's already taken, so we forget about it. So in this case, both of these groups direct to the same position. That makes it super, super easy for us. We know that we're choosing this position. And I told you guys we're going to do a halogenation reaction for each of these. So let's just say we're doing a bromination, right? So let's say we're doing a bromination for all of them, right? So in this case, again, I'll reiterate, since both of our groups directed to the same position, we have a lot less work to do. We know that our bromine will be added meta to both of those groups. Any questions? How do you feel about this so far? Someone said, can you explain why N+ is a strong deactivator? So yes, I can. First and foremost, primarily what makes it a strong deactivator is the plus. So since the nitrogen is positively charged, it's pulling electrons to it to try to satisfy that plus charge. So it's going to pull all the electron density away from the ring to the nitrogen. So that's why it's a strong deactivator. Because remember, all of our withdrawing groups are going... that was a weird hiccup cough. All of our withdrawing groups are going to be strong deactivators. Besides halogens, they're going to be weak deactivators. Did that sort of kind of answer your question? Okay, cool. You're very welcome. Okay, so I lied. Let's actually just do one more, because you guys are doing really well. So this group is going to be what? Activator, weak deactivator, or strong deactivator? Strong deactivator. Awesome. And so where does it direct? Meta. Perfect. All right. So what about this group? Activator, weak deactivator, strong deactivator. Strong deactivator, perfect. And where does it direct? Meta, perfect. So, meta compared to the green group will be here and here. Meta compared to the pink group will be here or here. So now they do not line up. So we have to figure out which one of these will be the director. Does anyone have any idea how we figure that out? If not, that's fine. We haven't covered it, I'll tell you, but I'm just curious. So someone said sterics. That is good, but that's a secondary decider. Okay, so cool. 2 people said... I lost. I can't read exactly what you said because I lost it. But it's the weaker deactivator. That is completely correct. So if we go here to our list, this is our strongest this is our most activating, and this is our most deactivating. So when we have multiple substituents already on the ring, and we're going to do a third reaction, the most activating group on the ring will direct the next reaction. So I'll say that one more time. When we have multiple substituents on the ring and we're doing another reaction, the most activating group will be the director. So what that means is whichever one of these is the weaker deactivator is going to direct the halogenation. So if we look back up at this chart, we know we're looking for NO2 or a carbonyl. So here we can see between NO2 and the carbonyl, which one is more weakly deactivating, aka which one is the stronger activator. I want a couple more people to answer, please. Between carbonyl and NO2, which one is the weaker deactivator? Cool, yes, exactly. You're all correct. It is the carbonyl. So in this case, the carbonyl, it will be the director. So these two green arrows will indicate the reaction. So I'm going to cross out the pink ones. So we will get two possible answers. NO2. I'm just going to write NO2. I'm not going to bother drawing it out. Because it doesn't really matter that much. Okay, cool. So this is one meta position. So let's add the bromine. And the other meta position is here. So let's add the bromine. And then, sorry, someone said something in the chat and I got confused. Okay, so what someone said is the one that's circled in green. Yes, so this carbonyl is circled in green. That one was the weakest deactivator, so we're going to go to the green, the corresponding green arrows. So we're adding here and here. And then someone had mentioned steric hindrance. So what I meant by that being a secondary effect is here we have everything kind of in one corner. That's less favorable than when it's kind of further away. So because of steric reasons, this one would be favorable. But according to Dr. West, these are both valid products, so you won't have to pick like between these two. They're both correct answers. So I will zoom out so you guys can see it. We're going to stop there for today. I'll send out the thingy one more time, the attendance sheet. Please do that. And then someone asked, is there a major and minor product? So no, in this case, we're just going to say that both of these are equal products. They're both going to be there in equal amounts. So I'm done torturing you for today. I will send you guys an email about Wednesday just to confirm. I will also send you guys an email about the exam review as soon as we have it confirmed with Dr. West. And yeah, you guys did really, really great today. I know I tell you this every time, but I'm so proud of you guys for sticking with the material, for being so dedicated. You guys ask wonderful questions. You guys have really, really wonderful participation. So you guys are doing great. I'm so proud of you. Have a wonderful day. And I will see you guys on Wednesday. And someone said, off-topic question, do you think I'm at a good place for the exam if you finish up chapter 15 today and tomorrow and begin chapter 16 by Wednesday. Yes, for sure. I think as long as you start chapter 16 this week, you'll be able to kind of get it done by next week, especially you. I won't say your name just because you said it privately, but I think you're really on top of things. So I think you'll be good as long as you start this week. You are very welcome, guys. Have a great day.